Yesterday we were doing that combination of capacitors, right? Parallel grouping of capacitors is going on. We got the expression for equivalent capacitance when three capacitors of capacitors C1, C2, and C3 are connected in series. So let us continue that. What is the serial number going on? 6 or 5?
Sir, 9, 8 was going on.
Okay, okay. So we got CP is equal to C1 plus C2 plus C3. I think we stopped here, right?
Yes, sir.
Okay. So it is also called as the law of capacitors in parallel. The effective capacitance of two or more capacitors connected in parallel will be equal to sum of their individual capacitances. That is the statement, of course, you get. Then here V is equal to Q by C is constant. That is, Q is directly proportional to C, implies ratio of charges on the plates of the capacitors Q1 is to Q2 is to Q3 will be equal to C1 is to C2 is to C3. In case of two capacitors in parallel, we get CP is equal to C1 plus C2 and Q1 is to Q2 is C1 is to C2. This implies Q1 is equal to C1 by C1 plus C2 into total charge, and Q2 is equal to C2 by C1 plus C2 into total charge. Yeah, please note down. Completed, eh?
Yes, sir.
Sixth one. In case of n identical capacitors, in parallel, we get Cp is equal to C naught plus C naught and so on n times. Okay. So n times. Therefore, we get Cp is equal to n into C naught. Note in case of two capacitors, Cs will be C1 C2 by C1 plus C2. Cp will be C1 plus C2. Therefore, the ratio will be Cs by Cp will come out to be C1 C2 by C1 plus C2 whole square. Then note 2. In case of n identical capacitors, Cs C naught by n, Cp n into C naught implies Cs by Cp is 1 by n square, or Cp is equal to n square into C naught, Cs. Sorry. So please note down. Okay.
Yes, sir.
Composite dielectric sand. So in this, These are the two plates of the capacitor. And these are the two dielectric slabs. Each dielectric is filling half of the plate separation. Like this. Such that this is d by 2, t by 2. It can be different also. So here, if you just discuss the charge distribution, here we'll have the positive charge, and by induction, this phase of the charge gets, this phase of the dielectric gets the negative charge, while its other phase gets positive charge. Similarly, this phase of the dielectric gets negative charge, while its other phase gets positive charge. As usual, the second plate of the capacitor will get the negative charge. So here, this is the dielectric slab of constant K1, dielectric slab of constant K2. Condition is each dielectric fills half of the plate separation. That is a condition. So now we can write the capacitance of the, we can assume that it is equivalent to two parallel, because the already we said the dielectric slab will be acting like, yes, a conducting plate with equal and opposite charges on its two plates, establishing a field across it. Therefore, the first plate of the capacitor and the first phase of the dielectric will comprise one capacitor. Similarly, the capacitance will become C1 is equal to A K1 epsilon 0 by D by 2, implies C1 will be, yeah, it is 2K1 C0. You know, C0 is A epsilon 0 by D. And the other half of the capacitor plate with other dielectric will have the capacitance of A K2 epsilon 0 by D by 2, implies C2 will be 2K2 C0, such that C1 and C2 are in series. So now their equivalent capacitance will become C1 C2 by C1 plus C2. So if you substitute these values, 4 K1 K2 C0 square by 2 into K1 plus K2 into C0. So finally we get C1 will come out to be 2 K1 K2 by K1 plus K2 into C0. This is when two dielectric slabs, each of dielectric constant K1 and K2 are filling the space in between the capacitors such that each dielectric fills half of the plate separation. If suppose plate separation is the thickness of the dielectric slab is not equal to half of the plate separation, then what will be the formula? Now we will modify the same equation. See that?
No, sir.
We can give some values and try some problems. Say K1 is 4, K2 is 12, C0 is 5 microfarad. So C1, you can find such, try such problems.
Sir,
Ah,
negative plate to positive plate now, sir.
pardon?
Here that uh, direction of electric field will be from negative to positive plate now, sir.
Already explained you, na?
Yes, sir. Just asking, sir.
E0 is the field from M to N. Okay?
Yes, sir.
Field across each dielectric will be opposite to it.
Since each one is completely filling, it will be opposite in direction of conventional electric.
Exactly. That's why after dielectric polarization, I have shown a single dielectric slab with the showing the field, applied field, field across dielectric, even polarization vector, all those things we have done. Okay,
Yes, sir.
to give you clarity only. A simple problem, as I said, K1 12, K2 4, C0 5. So the equivalent capacitance will be 12 into 4 by 12 plus 4. 4, correct? 48 by 16. 12 into 4, 48. 2 into 48 by 16. Yeah, 3, sorry. Into C0 5. So 16 threes. So 30 microfarads. You can expect in board exams. Completed, eh?
Yes, sir.
In this only, eight three A na? Okay. 2. Suppose half of the space is empty. If one dielectric fills half of the space, while the other half is empty. Then C1 becomes 2K by K plus 1 into C naught. Am I right?
Yes, sir.
Next, third point in this, if number of dielectrics of thicknesses T1, T2, etc. and the dielectric constants K1, K2, etc. are filling the space completely. Then the capacitance will become A epsilon 0 by T1 by K1 plus T2 by K2 and so on Tn by Kn. What do you mean by this? This is one plate. This is the other plate. No gaps are there. And so on. So this is T1, T2, T3 and so on. And the dielectric constants are K1, K2, K3, etc. In this again, if some intermediate gaps are there, if intermittent gaps are there, same thing we are extending, that's all. Then there we said D minus T, correct? D minus T into 1 minus 1 by K we put there. Do you remember or not?
Yes, sir.
So here it is D minus of T1 plus T2 and so on will come. That's all. So C becomes A epsilon 0 by D minus of T1 plus T2 and so on plus T1 by K1 plus T2 by K2 and so on. Or you can also write it as D minus of T1 into 1 minus 1 by K1 plus T2 into 1 minus 1 by K2 and so on. That way also you can write. Can I write here?
Yes, sir.
Completed. We will do it afterwards.
Sir, what is that in the last one, sir? If
Intermittent gaps are there, means the space is not here. The entire space is completely filled with dielectric.
Yes, sir.
Whereas here, intermittent, there are some gaps. The entire space is not filled with dielectric.
Yes, sir.
The same expression we can write in other way also. Already, if we are familiar with one expression, right? D minus T into 1 minus 1 by K.
Yes, sir.
When the dielectric partially fills the space, capacitance becomes A epsilon 0 by D minus T into 1 minus 1 by K. Formula is there with us.
Yes, sir.
In the similar pattern, we can write it. That will be easier for you. Completed, huh?
Yes, sir.
Okay. So the same expression can be written as C is equal to A epsilon 0 by D minus sigma I is equal to 1 to N Ti into 1 minus 1 by Ki, correct? Or C can be written as C naught by 1 minus 1 by D into sigma Ti into 1 minus 1 by Ki. That is, C becomes C naught by 1 minus of T1 by T1 into 1 minus 1 by K1 plus T2 by D2 into 1 minus 1 by K2 and so on. Just recollect the formula. When dielectric is partially filling the space, we got the formula A epsilon 0 by D minus T into 1 minus 1 by K, or we also wrote it as C naught by T by K into 1 minus 1 by D.
Yes, sir.
This is when dielectric is partially filling the space. Completed, huh?
Sir,
Yes,
1
sir.
minute.
Okay. This is the source of this formula, which we did already, derived it, in fact.
Yes, sir. Completed, sir.
Okay, good. Sometimes you'll be given capacitance without any medium and say some 5 dielectrics are filling the space, each of thickness 0.5 millimeters, 0.8 millimeters, 0.4 millimeters, each of dielectric constants 5, 4 and 8. So what is the capacitance? Then you should apply this formula and solve it. Okay.
Yes, sir.
Fourth point. Please write. Capacitor has square plates. A capacitor has square plates. Each of side L.
Sir, can you please repeat once?
The capacitor has square plates. Each of side L and are d meters apart. And are d meters apart such that one is inclined at an angle alpha with the horizontal. One is inclined at an angle alpha with the horizontal. So here the plate separation is not same in both the sides. This is the plate separation on one side, d1 is equal to d, and the plate separation on other side is d2. You know, this is L. So L alpha this will be D, this will be, because this is L. So this will be L sine alpha, correct? Because this angle is very small, it can be L alpha. So D1 becomes D, D2 will be D plus L into alpha. So whenever the plate separation is different, we can go for the mean distance, mean separation between the plates. It is D plus L alpha by 2. So we'll be getting it is D plus L alpha by 2, or D into 1 plus L alpha by 2D. So capacitance becomes A epsilon 0 by D into 1 plus L alpha by 2D. D by 2 will come na? Yes. No. D plus D, 2D by 2D. Yes. So this is the expression, means C becomes C naught by 1 plus L alpha by 2D, or you can even approximate it by taking to the numerator as C is equal to, it is L square epsilon 0 by D into 1 minus L alpha by 2. This is the expression for capacitance when the two edges of the two plates are at different distances. Okay.
Yes, sir.
Then fifth one. This is the given air capacitor with the capacitance C naught and the space in between the plates is filled with two dielectrics, each of dielectric constant K1 and K2, such that each is filling half of the plate separation. Like this. So, when some charge is attempting to flow, because the dielectric constants are different, hence each half interposed between half of the plate area will act like a separate capacitor. Therefore, because the capacitances are different, hence each half will draw the charge as per its charge bearing ability. Therefore, a charge Q1 will be coming towards left side and the remaining charge Q2 will be going towards the right side. As a result of that, so this is the charge on one portion. This is the charge on the other portion. So by induction, here we will get the negative charge like this, and here we will get the positive charge on the other face of the dielectrics. And lastly, here negative charge. Like this. So this is the plate separation. Now, this will be equivalent to two capacitors, each of plate separation D, plate area A by 2 filled with two dielectrics of constants K1 and K2, such that C1 becomes A by 2 K1 epsilon 0 by D and C2 becomes A by 2 K2 epsilon 0 by D. So thus C1 will be K1 by 2 into C naught and C2 will be K2 by 2 into C naught. Because the charge is getting distributed, hence C1 and C2 can be considered to be parallel. So the effective capacitance in this condition context will be C1 plus C2, means I get C0 by 2 into K1 plus K2. Here also, if half of the space is only filled with dielectric, then we'll be getting it as C0 by 2 into K plus 1. That's all. Suppose if n number of dielectrics are kept, then C0 by n into K1 plus K2 and so on Kn. Correct?
Yes, sir.
Yes. For n dielectrics, C2 will become C0 by n into sigma Ki. I am assuming that area is equally divided by the capacitors. So if you use same values of dielectric constants and capacitance, which we did already, then here C2 will become 5 by 2 into 16. 12 and 4 we gave. So this is, you will get 40. Same values I took, whatever we did for earlier arrangement. Here I took same values. C0 5 microfarads, K1 is 12, K2 is 4. So if I do that, I'll be getting 40 microfarads as the equivalent capacitance. Shall I continue or stop? Yeah. Ramakrishna.
Sir, your choice, sir.
Sir, stop, sir.
You have class, huh?
Yes, sir. We have to ready for the next class now, sir. Hostel.
Okay. No, at what time you have the class?
Sir, 8:30, sir.
7:30. 1 hour is not enough for you. Huh?
Sir, here today some problem is there, sir.
Okay. Okay, then we'll conclude here, right?
Thank you, sir.
Okay, sir. Thank you, sir.
Okay.
Thank you, sir.
Okay, tomorrow I'll continue. What about tomorrow? Shall we have any extra class? Because next week you may have some 2 or 3 holidays.
Yes, sir. For
Okay, sir.
Dasra,
Uh,
we are having Dasra holidays for 4 days like that.
no, that's what. So, if you want, tomorrow we can have a class.
Yes, sir.
Yes, sir.
Yeah, shall we keep it at 10 to 12?
Sir, tomorrow there is college, sir, so it should be at the same time.
Okay. Sunday college is there.
Yes, sir.
Only
Only
tomorrow.
this Sunday. Only this Sunday.
Okay. Fine. We'll have tomorrow, right?
Yes, sir.
Yes, sir. Thank
Yes, sir. Okay, sir.
Thank you, sir.
Thank you, sir.
Okay.